Alright, welcome to your Lab 7 video. We have a few things that you'll have to take notes on first, and then I'll go through the lab with you. So please make sure that as you're watching, if you need to pause so that you can write down the notes, please do that, so that you have all of these things, because you will need them when it comes to your analysis. Okay? Alright, so the first thing that we need to talk about today are the differences between physical characteristics and chemical characteristics. Okay, so, or physical properties and chemical properties. Okay, and I'll put these over here. Okay, so physical properties, okay, are properties that, or characteristics that are going to be the same regardless of the amount or the shape of the substance that you have. Okay? Okay, these characteristics stay the same. Okay, so for example, let's talk about paper. Okay, paper has physical characteristics that it is composed of wood. Okay, it always, you know, in our case, for example, let's say like this paper is white. Okay, and whether or not I rip this paper in half or I crumple it up, that characteristic is going to be the same. So some examples of those are going to be, let's say, color, density, and we'll talk a little bit more about density in a minute. Color, density, conductivity, and we'll talk about that in a minute too. And malleability. Malleability is just basically the ability to flatten it or to change its shape. Okay, and I will move you guys closer so that you can see. Okay. All right, whereas chemical properties are going to be the characteristics that allow the object or the matter, okay, that allow it to like change composition completely. Okay. Okay, and so basically a piece of paper has the chemical characteristic of being able to burn. Okay, that's a chemical property because once you burn this piece of paper, the matter is changed completely. It's actually what we call a chemical change as opposed to a physical change, because you can't really change it back. Okay, so we'll say the ability to burn is an example that you can use. Okay, awesome. We also have chemical and physical changes. So a physical change a physical change is when you have a state change, or like going from, let's say, liquid water, okay, and it freezes and it forms ice cubes. Okay, we still have H2O, we still have water. The actual matter didn't really change at all. What did change was the state of matter that it's in. So it went from a liquid to a solid, or it could have gone from a liquid to a gas. It could have evaporated. If that was the case, then that would be a physical change. Okay, another example of a physical change is if I took this piece of paper and I completely just ripped it in half. I changed the amount that I have, but I didn't actually change the composition of the paper. Okay, whereas a chemical change the actual composition of whatever the matter is changes. So like I said earlier, with the paper, the ability to burn, once you go from having like a piece of paper, okay, you basically, if it burns, then you have ashes. It completely changes, okay? It completely changes, that's on fire by the way. So the paper burns and then you have ashes. So it changes completely, it changes the matter completely. Okay, that's super important for us to understand. We're also going to talk about 3 different properties today that relate specifically to the lab that you're going to do on the solids that were in your mixture. Okay, so in this little jar right here, you can see the solids are in here. The 2 heavier cylinders, and there's a red colored cylinder and a little black square. Okay, those are the 4 solids that you're going to be testing for our 3 properties today. Okay, I'm going to let you get a closer look at the notes so that then you can take some notes really quickly, and you can pause it here if you need to so that you can take the notes. Okay, all right, now I'm going to go ahead and erase what we have. Okay. Okay, awesome. So we have 3 properties that we're going to talk about today. Conductivity, okay, is our first one. And conductivity is essentially the ability of a substance to transmit the flow of electricity. Okay, so for example, metal is a really good conductor of electricity. So that's why a lot of wiring is made of metal on the inside, because that will take electricity from point A to point B very easily. It's a very good conductor. So we say it's a good conductor because it demonstrates that that metal has good conductivity. Okay, an example of a substance that does not have very good conductivity is rubber, for example. So you see a lot of wires, like these wires, for example, they're covered in like a rubbery, plasticky substance. That's because rubber and plastic do not conduct electricity very well, and so electricity just doesn't transfer as easily through that substance. So the conductivity is fairly low for those substances. Okay. All right, so metals are good conductors. Okay. The second thing that we're going to talk about now is density. Okay. Okay, density is the mass per unit volume. Basically how tightly packed the molecules of a substance are. Okay, so so for example, okay, in your lab today, this will be really important for you to note. Okay, ethanol has a density. Okay, ethanol has a density of 0.79 grams per cubic centimeter. Okay, so that means for every cubic centimeter, imagine one of those little centimeter cubes that we used to use in math, that you probably used in math a while back. Okay, that means that it has 0.79 grams of ethanol for every cubic centimeter. Whereas water, okay, has a density of 1.0 grams per cubic centimeter. Okay, so it actually has more molecules per cubic centimeter, so that means that the density is higher because more molecules are packed together. Okay, so what that really looks like is if in your cubic centimeter, it really just means that the molecules are packed really tight together. Okay, whereas with ethanol, they're packed a little bit looser. So they're still not, super far apart, but they're not packed nearly as close together as water. Okay? All right. Our last one that we're going to talk about is reactivity. Okay? If a substance is able to react chemically with another substance, that's its reactivity. Okay, we're going to do tests in the lab to demonstrate these three properties. I'll get you a little closer so that you can kind of see all these notes if you need to take notes again. Okay. All right, so here is kind of how you are going to work in your lab today. Okay, you have your 4 substances. You'll do each test on all 4 of them. Okay, you're also going to use this properties of separated solids. You're going to use this sheet in your lab. It should be in your notebooks. Okay? So you're going to go through each of the solids to do each step. Okay? You have a ton of different materials in your lab book that you will need. Okay? But it is really important, remember, to do each test on each one. Okay? The first thing that you are going to do is you're going to test the electrical conductivity, okay, of each substance. So what you have here is a battery, and you're basically going to create a connected circuit and see if the substance transmits the electricity through this. So you have these 2 ends of the wire here, and you're basically going to connect them and see if this little light bulb lights up. So you can see right here, if I connect them, the light turns on. I'm actually a conductor of, not a very good conductor of electricity, because if I put my finger in between these 2, it does not light up the light bulb. Okay, so you're going to see, you have to touch the object with both of these at different points. You don't want these to be touching, otherwise it'll just conduct the electricity through the metal itself. So they have to be connected on different parts of like maybe the top or the bottom, or a corner to a corner of each of the substances, so that they're not touching themselves. Otherwise, it'll just light up because the metal is touching. Okay? Also be careful if the rubber part gets in the way. Remember, rubber is not a great conductor of electricity, so if I just touch the 2 rubber parts together, it's not going to light up the light bulb. So you have to make sure to use the metal. Okay? The next part that you're going to do is, please, by the way, follow the procedure that's in your lab manual in your book, okay, in lesson 7. I'm just kind of giving you a quick overview, but it'll tell you exactly what to do in that lab manual. You are going to have ethanol, and you're going to have a little squirt bottle of water. You also have water in here, so please follow the directions in there. But you're basically going to see if it is more dense or less dense than water and ethanol. Okay, and how you can tell is if it floats in the substance, it is less dense. So like ethanol is less dense than water. Like let's say that I had something and it floated in water. Okay, it floated at the top of water. That means it is less dense than water. But let's say in ethanol it kind of sinks. Okay? That would mean that it is more dense than the ethanol. So the density is then going to be somewhere in between 0.79 and 1. Okay? But if it floats in water and floats in ethanol, that means it's less dense than both of them, which means that the density is even less than 0.79 grams per cubic centimeter. Okay? If it sinks in ethanol and sinks in water, then you know that the density is greater than 1 gram per centimeter cubed. Okay? So that's kind of how you'll do the density test. You'll float the things in the substance, and it'll tell you exactly what to do in your lab manual and how to do that. Okay, and the last one that you're going to do is reactivity, and you have this little, it's called copper chloride, okay, and it's blue. Okay, anytime you see a chemical change, it will either change color, it will bubble, things will get cloudy, the temperature might change, or it might form a precipitate, but we'll talk about that later. So those are different signs of a chemical change. Remember, color change, bubbling, cloudiness, temperature change, etc. So when you drop drops of the copper chloride onto each of your items, you're kind of looking for any of those signs to see if it reacts chemically with this. Okay? Please go ahead and do your best. Follow the directions exactly in your lab manual, and best of luck to you. Also, please do not spill any water on this. It is electric. It will complete the circuit, and it's not good. I do not want any of you to get shocked. Okay? Thanks. All right, good luck.